Okay, good afternoon. Today I'm going to talk about XtraDB clusters CI testing, as this mini conf is about. Okay. Hope you had a good lunch and not too much carbohydrates, since it makes you sleep. Okay, so this is the basic outline. Okay, why, so the first question is why do we waste all the time with the CI testing? I mean, I think the answer is obvious. The developers need more free time to think and to do other things. So I just linked to this XKCD one. It's not directly related, compiling, but so having a CI allows us to do other things. They are fencing there, but other things as well. On a serious note, when there was less or no CI, it was very hard. It is and it can be very hard to test all the known points of failure of something like PXE, which is basically, as I say, the PXE and Galera. PXE is nothing but MySQL. I think all of you know about MySQL. So this is synchronous replication added to MySQL. And Galera is an external library which facilitates this communication between homogeneous MySQL instances. So that is the PXE and Galera part. And MySQL testing framework, I'm not sure how many of you are aware of it here. It's called MTR, and that is being used here. That is one of the components. It's not the entire thing. And when I say reuse, what I mean is I'm using a lot of reusing a lot of the components which are already being tested. But again, since this is a cluster, some changes are required. So I'm not testing a single server. I'm testing a whole cluster, like 2 or 3 nodes or more. So the role of communication, networking issues, locking issues, particularly locking since it's a distributed transactions will be there. So the locking issues will be prominent. And latency, that is the final thing which can be a really bad killer, particularly in synchronous replication. Okay, so the first thing which comes to mind, at least to my mind, when somebody says continuous integration is nothing but Jenkins. So the way we have Jenkins set up is that when I do a VCS check-in, the VCS we use is Bazaar. Okay, fine. Then today I read on LWN of an article from Eric Raymond who said that Emacs should move from Bazaar to Git. Anyways, so from a VCS check-in and to the building of packages. So the whole thing is set up like that. The VCS check-in triggers polling. There's a polling which is set up on the Bazaar repo, and that in turn triggers builds, and then the tests, and finally the packages, because of course we need feedback, continuous feedback on the packages which have been built. So those are required. It's not just the tests, it's not just the continuous testing which we rely on, but also on human feedback, because of course that's necessary. Anyways, so as I said, that's the manual triggering versus polling. I'm not sure how many of you are using Jenkins actively here, but I think you can make out from that. Manually triggering is where I call the first build remotely, and that triggers the rest of the builds. Polling is where it periodically polls like 5 minutes or 1 hour or something like that. And there are dependencies and blocking. What I mean by that is between the build job and the testing job and the packaging job and the VCS job, there needs to be dependencies which are created here, and there's a build blocking also. Sometimes I need to block a certain dependent build so that a build A is complete. Only after build A is complete, build B is triggered. Things like that, because one, it is to save the hardware resource, because I don't want to trigger duplicate builds. So that is the blocking part. Okay, anyways, the workflow, one of the main components of our workflow, at least in PXE, is the parameterized triggers. What that means is, from VCS, we use Launchpad, and I'm not sure how many of you, again, use it on a daily basis, but it's not fastest of its kind when you do a VCS clone. So when you do a VCS, we want to avoid duplicate clones. So what we do is we have a separate job for just for the cloning from the launchpad, and rest of the jobs make use of that tree which has been cloned to reduce the network I/O. So the part played by parameterized triggers is the rest of the jobs will require certain parameters from the VCS clone, things like revision, bazaar revision. Now what happened here? Oh, okay. I'm not using Unity, but I don't know. Okay. I think it's the DPMS. Anyways, okay, never mind. So yeah, so that's the VCS cloning part. Yeah, so the triggers. Okay. Okay, so certain parameters will need to be passed to the jobs ahead of it. So that's the part of the parameters. By the way, we are using the Bazaar plugin for Jenkins, which I think many have written, including Stewart, some others, and I think some from MariaDB as well, I guess. Anyways, so that's the build, plumbing, and fork and join. What I mean by fork and join is, so VCS job, VCS clone creates triggers like 3 jobs. So we have to wait for all of the 3 to complete to run further tests or to trigger packaging, because it doesn't make sense to have packages where the tests have failed, right? So that's what I mean by fork and join. So it has to wait for all the jobs to complete, and only then it can proceed. And then there are matrix builds. This is a matrix build is something which was which I found curious when I started using Jenkins. It had a picture of matrix reloaded and all that thing. Anyways, so what this is, this helps when you're doing build for many platforms. Currently we have like 13 into 2 builds, so that's like release and debug builds into 13 different distros and 32-bit and 64-bit. So when one of them fails, it doesn't make sense to trigger all of them again, right? So this is where we use matrix builds to do selective rebuilds, and so that the job is finally green. Okay. So the next one is sysbench. I think most of you may have used or heard of it. Though the latest sysbench is not packaged yet in the distros. I think you may have used 0.3 or something, but the latest one is only in the launchpad. Anyways, so we use one of the features of that, which was recently added on my request, because the developer of sysbench also works for Percona. So it was for simultaneous dispatch to all the nodes. Because that is what we require when we test a cluster. We want requests to be dispatched to all the nodes at the same time, both read and write requests. And since this is a synchronous replication, we want to be really strict about several things here. And we reuse MTR here. Again, we use that to start and stop servers and things like that. It's but it is its scope is much larger than that. But here it is used only for that. Again, what is sysbench used for? One is benchmarking. I think that should be obvious, because sysbench is basically a performance testing tool. So what we do is we keep a history from every test, and then finally we do a graphing, and we can see where, so that we can easily find out the commits where there were performance regression was triggered. It saves us from bisecting the tree again, which can be tedious, very tedious. Okay, anyways, the next one is testing. This is something not used much. I mean, sysbench is not used for testing, but basically the reason why I added it is there are certain bugs which are triggered only when you are doing a performance testing. I mean, only when there's a high load, when there are really high number of threads, when your aim is to test the performance, there are bugs which can be triggered at that moment. So, since this is a synchronous replication, we use sysbench for testing that. And there are many issues which we have found out through that, many crashes actually. Since this, basically the PXE involves transactions which are sent to other nodes. There's something like pre-commit stage. So once all the nodes agree on it, and only then the apply happens. So otherwise there will be rollbacks and things like that, or sometimes in some cases the transactions on other nodes, they are aborted. since since those things are involved, the sysbench testing helps a lot here. When I say BF aborts, it's a brute force abort. When a local transaction is killed to make way for a global transaction. So there are a lot of complexities involved here, I think you can see. And then this is.
I deeply apologize if I missed this earlier because I was late. And how do you get multiple nodes out of Jenkins?
It's not on the Jenkins. It's the sysbench test. The Jenkins, the sysbench is one of the tests on Jenkins.
Right, but it says all nodes.
Yeah, so the sysbench, you can use like MTR and start many nodes at a time, and then you can start sysbench separately, and you can have it dispatched to all the nodes through sockets. It takes like do all the sockets at the same time. And one of the properties of sysbench is they have optimized it so that it does not involve any latencies of connection creation and teardown. So it creates one connection, and it keeps dispatching the requests.
It's just on one physical machine, though. If you're asking about.
Right. So node to me means physical machine.
Yeah. For us, it's just software process.
Okay. Thank you.
Yeah. So there are like so there's like CentOS 6 32-bit, CentOS 6 64-bit, things like that. CentOS. Okay. Anyways, the next one is RQG, which stands for Random Query Generator. It's an immensely helpful tool which has been used not just in MySQL but also I think in PostgreSQL and Oracle as well. One of the things which is used there is combination testing. I'm sure you have used many applications which have like hundreds of options. May not be hundreds, but at least as many. So many times you would like to test all the combinations. There are many combinations which won't be tested by regular user usage. So those things are often the sources of bugs, and you don't want to wait till the user reports them. So this is what helps in the combination testing, where you can test different combinations. But as you may have guessed by now, if you test all the combinations, it can be very, very large. So some kind of pruning is required there. And there are configuration changes which you can do for that. There are other ways of pruning, but I wouldn't go into that now. But it's something which requires manual tuning to reduce the number of combinations. The combinations which are not the right ones logically, not in terms of application. As I said, the corner cases are where the bugs usually tend to hide, and you would like to test them as much as possible. And the second part is stress testing. One of the other aims of random query generator is to test it with all possible queries. I mean, it generates queries which a normal user or a normal application may not even use. The aim is again, but we have seen some edge cases where users have like very, very eccentric queries. Anyways, so this as I written there, MS, MMM. I'm not sure if you are aware of MySQL async replication term, but this MM stands for master master, master slave, master master master. Now you may be wondering why I'm saying that master slave and all in this synchronous replication. But basically what I'm saying here is that the role, it's the role. So when I do a MS testing, I'm writing to one node and reading from the other node. Also reading from the first node as well, but you get the point. And as I said, the locking bugs have been really problematic since the testing has been started, and we have recovered a lot of issues. Basically with the DDL and MDL. The DDL stands for data definition language, for those of you not aware. And the MDL stands for metadata locking. Metadata locking was introduced in MySQL in 5.5. And it has been there since. It is mainly used for DDL, and since in PXC at least, when there are distributed transactions, the locking can be really a source of headache. So that has been tested, and other kind of locks like InnoDB row deadlocks. InnoDB, even if it has lower granularity locking than MySM, it still has row locking. So There can be row deadlocks, and which are not that bad, but they can introduce a lot of rollbacks and brute force aborts, and can introduce latency. So it is good to debug them as soon as possible. And finally, the hung tests. By that, what I mean is there are many times when there can be serious bugs which can cause the server to deadlock. But what I mean by deadlock is that it doesn't take any queries further. So there are a few things we have done there as mentioned in the talk earlier, like a watchdog timer. So it checks if the server is up or down every few seconds between the queries, and if it's down, what we do is we send a 6egue and it triggers a backtrace, and we get BT full, thread deploy, all BT full and things like that. And from that, it's much easier to debug why the server was hung. And this is the end-to-end testing. Also, it works as smoke test. So the point of this is that every system has one of those things which is one of the critical components of the system, which also means that by testing which you can say that the system works as expected. So snapshot state transfer is one of those things. Basically, what happens is, as I've said in the flow, you start a node, you load it with data, you start another node. The another node starts a SST. By that, what I mean is the state of the node 1 is transferred to node 2, and then on node 2 I checksum, so to make sure everything is working as expected. And it uses extra backups test suite, because SST is done with extra backup. For those of you not heard of extra backup, it's basically a backup utility for MySQL, which is mainly used for InnoDB, and which uses very less locking. Anyways, so since that is a critical component, we use that for end-to-end test. Anyways, and one more function of this end-to-end test is to test on different platforms. We don't want, since some of these tests involve, some of these components involve distro-specific scripts, there can be issues on different platforms. So one of the side effects or one of the side advantages is we test different platforms as well. So I have written the 13 supported ones. So we support Debian and CentOS and Ubuntu, and their variants. So that becomes 13. Anyways, so the outcome is that I know that after I release the package, nobody comes with the trivial bug saying, it doesn't start at all. I won't get bug reports like that. So I can be sure that it works. At least it does this. Finally, there's this replication testing. There is a certain degree of overlap with other tests in coverage of this replication testing. This I had written basically to test replication between major versions like 5.5 and 5.6 and vice versa, to facilitate rolling upgrade, which can be very hairy at times. So this is for testing upgrades and downgrades. It reuses earlier tests which I had mentioned, like MTR, Sysbench, and SST. It basically starts a node, it loads it with data, starts second node, SST happens, then you upgrade this node, then you shut down this node, and then you bring it up again, and then you run queries to make sure everything works. So there are a lot of things involved in this. But again, this helps a lot with testing the replication between major versions. But it can also be used for like 5 minor versions as well, but there's no point since other tests cover it already. Okay, miscellaneous, this is some of these techniques which I had used. You may notice them if you have. This lock wait timeout is not the InnoDB lock wait timeout. You may be thinking of it's the MDL lock wait timeout. Basically, it is set to 1 year by default. I don't know what's the reason for that. What happens is, when it's set to 1 year, the test can hang for a long time, but without revealing where the problem lies. So what I had done was I set it to a very low value, like 50 seconds or something like that. And what happens is when there's an issue, it crashes. It's always better when you are debugging for a server to crash, so you can get valuable backtrace and things like that. Or it may hit assertions in the debug builds. So as I've said that we use we do releases of the release builds, but we also do unib debug builds, which So the unit debug builds are basically with more debug info. It's not your the GCC debug info, but the debug info which is in MySQL itself. So it has like more asserts and more checks, more runtime checks and things like that. So in the debug ones, it hits assertions earlier, and so you know where the problem lies. Otherwise, what happens is many times it crashes several call chains away from where the problem is, and you won't know what's the problem. Like sometimes you get like double free or crash kind of a malloc corruption or a heap corruption, and most of the times it's nothing to do with where it has crashed. It's the corruption is introduced somewhere earlier. Okay, and so this is the future. We want to test at a higher level with Chef, Puppet and all. It helps in testing packaging. It also helps with destroy idiosyncrasies, especially with Debian. We have had certain idiosyncrasies exhibited by it, for which we had to do many fixes. Anyways, and automated handling of test results. One of my colleagues is already working on this. So like when you get the results, basically we run a very large number of tests. So analyzing each and every one of them when they have failed, especially when many of them have failed, and examining them visually can be tedious. So some kind of automated handling of test results is good, like extraction of backtraces. This I also worked on, like to get backtraces and also to do bug reporting, to Launchpad. We use Launchpad for bugs, by the way, like OpenStack, I think. Okay, who says testing can't be fun, I mean, you have time and you have resources, so it can be fun, I think. Sometimes I may disagree with that, but many times it's fun. Anyways, so this is the URL. All our testing is done in open, as in like on Jenkins, and the Jenkins URL is public. You can see it anytime. And we use Bazaar, Launchpad, IRC, Git. Actually, recently, I think Stuart worked on migrating it to Git, but we have not migrated fully. But who knows? Launchpad may set soon or when.
I think this makes me the most recent contributor to Bazaar, the person who's written any code for it, fixing visit fast export, get all the data out of it.
Yeah, I think Canonical was working on Bazaar.
Anything else that's broken in it?
Yeah, VZR is now my fault.
I think someone from Canonical was working on it, but then he quit it and he made a blog post on Bazaar. Something.
Are any of those people sitting in this room?
I think he's speaking of Yama Vunui, so they did a particularly poignant blog post. People keep telling me I should do one.
But Bazaar works, but sometimes I get Python backtraces when I'm doing something. Anyways, so there's a degree of overlap among tests. It is important because many times a single test may miss it. So we want, if the bug is missed in one place, we want it to be caught somewhere else. So that is one of the things which I intended with these tests. So there is a degree of overlap, and that's very much intended. And having multiple platforms also help there, because it may not trigger on this, but it will trigger on that. So, and sometimes some like glibc can be different between CentOS and Debian and Ubuntu, so it helps there as well. I think that's it. Thank you. Yeah, do you have any questions?
Questions? Time for questions, yes. And at the same time, Robert can set up if we want to be double time the whole thing and be on time.
Efficiency?
Efficiency. I know.
I was wondering, with your multi-node stuff, when you're testing replication,
Yeah.
given that Jenkins can control many nodes, but all the nodes are independent, how are you dealing with provisioning a whole cluster setup and then getting it to cooperate for a test?
Okay.
Is that just manually scripted?
The node provisioning is not done on Jenkins. On a single node, okay. On a single node, the different nodes of the cluster exist as processes.
Right.
So that.
You're scripting it within one Jenkins.
Yeah. So we use, as I said, MTR, right? MTR can be used to bring up more instances.
Yeah.
Whereas RQG has a native support for for the Galera, creating Galera nodes, multiple Galera nodes by default. You don't need separate processes there.
But basically, you find all the bugs with these small data sets that fit in a single machine.
That is my concern.
Yeah, you can get stuff that's much larger ones, but they're relatively rarer, and you can usually pare it down. And there's some stuff that's bigger, but for the most part, it's not greater than a single machine is. Yeah, still there. Like you get a bit more disk or a bit more data, you'll find more than enough problems in mere megabytes or gigabytes of data.
Yeah, that's true. But also, as I mentioned, I do the sysbench testing as well with high load and mostly with debug builds. So with the debug builds at a high load, when there are issues, it tends to crash. With assertions, when you use UniDebug with MySQL, it has assertions at almost every level. I mean, and it checks those assertions and it hits them and it crashes. The closer to the crash you are, the better it is in debugging.
Using suspense for load is great.
Yeah.